our last lesson, lesson 19, we're talking about expected values and odds. All right, this is going to be kind of short. So let's get after it. There are two types of odds in favor and odds against. For odds in favor, list the total number of ways the event to occur, followed by the total number of ways the event cannot occur. So can versus cannot. And then the odds against are just the opposite of the odds in favor. So you switch the numbers. You can list odds with a colon, so 1 colon 35, or you can say the word 2 in between, so 1, 2, 35, or you can use the hyphen. All right, if you run into this situation, like 2 comma 34 or 2 colon 34, you have to reduce that. That would be 1 colon 17. You must reduce these if you can. All right, odds are different than probabilities. Odds are can versus cannot. Probabilities are can over outcomes. So it's a little different. So number one, we're dealing with odds. Suppose the odds are in favor of a president being reelected 4-1. What are the odds of the probability? What are the odds against the president being reelected? Well, if the odds for him being reelected are 4-1, then you flip the numbers and it's 1-4. Okay, now the probability in favor of the president being elected. All right, remember, it's odds are can versus cannot, and probability is can over outcomes. So to get the outcomes, you add these numbers up, you get 5. So what are the chances that he can be elected? 4. So that would be 4 over 5. So 4 over 4 plus 1, you get 4/5. The chances of him not being reelected are 1 over 4 plus 1. So outcomes, can over outcomes. So this would be 1 over 5. So you have 1-4, you have 4/5, and you have 1/5. Right. So odds and probabilities are similar, but they're different. So make sure you can tell the difference. All right. Now, expected values are simply this. Expected values can be used to predict the average outcome of an experiment when it's repeated many times. Expected values cannot be used to determine the outcome of any single experiment. This is your formula. That big E thing is a sum, and all you're doing is you're taking each outcome and multiplying by the probability, and you're going to add up all your options. Okay, and then when it comes to expected values, you also have this thing called a fair game. A fair game is when payoffs are involved and the net winnings, the expected value minus the cost to play are exactly 0. So if the chances of you winning money is equal to what you pay to get into the tournament is equal, then it's a fair game. Then it's considered fair. So if the cost, for number 2, if it costs $5 to play a game where 2 coins are tossed, you receive $10 if 2 heads occur, $5 exactly if exactly 1 head occurs, and nothing if no heads occur. Is this a fair game? So if my chance of winning equals my cost to play, then it's fair. That's what we're checking out. So my cost to play is $5. Cost is $5. My winnings are, if I have 2 heads, I get $10. If I have 1 head, I get $5. And if I get 0 heads, I get $0. Okay, so using this formula, here's what we're going to do. Well, first of all, we need to figure out what the odds are. If I have a coin and I flip it, I can either get heads or I can get tails. If I flip it a second time, this is a probability tree. You may have seen it before. If I flip it a second time, my chances are heads or tails, heads or tails. It's always an option. So the chances of getting 2 heads are 1/4. That happens 1 in 4 chances. The chances of getting a heads and a tails is 1/4. The chances of getting a tails and a heads is 1/4. The chances of getting 2 tails is 1 1/4. Okay, so if I compare this to what I need for my winnings, if I get 2 heads, I get 1/4. But if I only need 1 head, it doesn't matter which order it comes in. That actually is half of my chances, because 1/4 plus 1/4 is 1/2. Okay, well, if I'm adding this up using that formula, I have 1/4 chance to get $10, plus 1/2 chance to get $5, and 1/4 chance to get $0. Okay, and that's going to be 10/4 plus 5/2 plus 0. All right, you can add this in your calculator or you can get a decimal or whatever, but that's going to give you 2.5 plus 2.5 equals 5. So here's the idea. I wanted to know if this is a fair game, which means the cost of playing, $5, is equal to my chances of winning. And again, the cost of play minus the expected value should get it 0. This is more than 0. So the chances are really good that I'm going to make some money. In fact, half of my chances I make money. So this is a better than fair game. You won't see this very often, but like typically carnival games are in favor of the house. Casinos are in favor of the house. It's a long shot for you to win. If we got an answer of 0, it would have been a fair game. We got an answer of 5, so this game is more than fair. You should definitely play. All right, guys, that's our last lesson. If you have any questions, please feel free to reach out anytime, and I will see you later.